Hello, welcome to Open Source CNC. Here we create toolpaths in FreeCAD and Blender and we run them on the machine. And in today's video we will also use Universal Gcode Sender, another free open source program. In this video, we are going to use a 3D probe. I'm going to show you how to set things up in Universal Gcode Sender, where to set the origin, how to set the probing, how to adapt it in FreeCAD, and I will also show you a very useful macro that turns the surface into a 3D object. And for the ones that are not familiar with FreeCAD, I will show you how to use solely Universal Gcode Sender for probing the surface and adapting the toolpath to that surface. Let me tell you why I think that the probe is really useful. It is useful especially when engraving things and when using the V-curve operations, because if the material isn't perfectly flat, the lines won't be as they should. So probing the material and getting the exact shape that the material has is a great addition to any CNC, especially smaller home-built CNCs that don't have perfectly flat surfaces. So let's go to the computer and start today's episode. Before that, I want to thank everybody that's supporting me here on YouTube, on my Patreon page through subscribing, or on my Ko-Fi page where you can download for free all the assets necessary to get what I do in the videos. Let me start by telling you a little bit about the piece of material that I have here on the table. It's a piece of oak and it is really wavy. I did this using a 3D surface operation because I wanted it to be exaggerated, so it is easier to see in the video what I'm talking about. So let me quickly set up an engrave operation and I will engrave on this surface the logo of my channel, the logo of Open Source CNC, using a 90 degrees V-bit. Just a quick info, I'm using FreeCAD 1.1 development version, the latest test version, and I'm going to switch to parts workbench. After that, let's import the logo. It's an SVG, so I will select SVG as geometric, click on open. If this warning appears, I recommend using the 96 dpi, click on yes. And I have everything imported. The text isn't as it should be, I don't really need it, I just want to engrave the logo, so I will select them in the tree and press delete button. Here I have 5 objects, let's select them all using shift key and create a new compound object out of them. So let's press F2 to rename it logo. But I'm not sure where it is positioned, so let's turn on the visibility for the axis, for the origin, and we will be able to place it correctly in order to be easier to mill in Universal Gcode Sender. Let's go to the Edit menu, go to Preferences, go to Display, and here check the Show Axis Cross by default, click on OK, and you will have here the starting point, the origin, and the 3 axes. As you can see, the logo is in the negative zone of the y-axis. I want it to be moved in the positive zone, so let's select it, go to Placement, Position, and at the Y field, I can either write a value, let's say 90, and it moves. I can scroll the mouse wheel and it will move upwards, but I want to be more precise. Let's change this value using an expression. Click on this little icon, and here I will use a formula to reference its own dimension to move it along the y-axis. Let's press dot, which means it refers to itself. Shape, bound box, dot, y, length. Take good care for upper and lower cases and for the dots, otherwise you might end up with an error. You can see the result here, 98.94 millimeters. Click on the OK button, click away, and now the object is perfectly positioned starting from the x-axis. Everything is ready. Let's go to the CAM workbench and quickly set up the job to create the engrave operation. Let's first select the logo, click on the New Job button, make sure it is selected here in the 2D group, click on the OK button, and you will end up with this job edit dialog. Let's quickly set things up. If you want more information about how to create jobs, you can find videos on my channel about doing this. Now I'm just going to quickly set up an engrave operation. Let's go to the Tools menu, click on the Add button, and I will select the 90 degrees V-bit. Again, if you don't know how to add a toolbit to this menu, if you don't have it here, here is a video about how to do it. Click on the Add Tool button. Let's give some horizontal and vertical feed speeds and a spindle speed of 20,000 RPM. Now I can remove the default tool because it clutters the list here without any reason. That's all I need to do. The origin is correctly placed. You can see it right in the corner of the logo. One more thing that I need to do before closing the job dialog is go to the Output tab, and here make sure I'm using the correct processor for my machine. In my case it's GRBL. Click the OK button to close the job, and now we can select the model. You can find it in the model group under the job, and create the engrave operation. Well, not really, because I need to select only the lines. I can do it by holding the Control key and selecting them one by one, which is really annoying. Or I can select a few of them and click on this button, which is Finish Selecting Loop. You can see that it added to the selection the entire loop, all the segments from this part. But I still have these parts. I can repeat the operation, or the easier way, select the model again and run the Only Edges macro. This will select all the edges of the object that is selected. If you need this macro, you will find the link to it in the description of the video. There you can download it for free or together with a small donation. Now let's create a new engrave operation. Click this little icon here, select it from the list. The only thing that I need to modify here is the final depth, which I don't want it to be -10, I want it to be -1, but I cannot simply modify it. I have to edit the expression, either right here -1, but it's not a good thing. Just click reset, and now I can easily modify the value here, so -1.0 millimeters. Click on the apply button to see what happens. You can see that the toolbit is going to follow exactly all these lines 1 millimeter below the Z0 surface. Click on OK, and now select the job, click on Post Process, which will output G-code according to the machine to what I've selected when creating the job. Click on OK, and then save the file so we can move to Universal Gcode Sender and run the operation. Obviously, I'm playing a game here. I'm assuming that I don't notice that this surface has some very small bumps, which aren't that small. This means I will place the tool setter here, clip the other cable to the spindle, and now let's move the spindle above the touch plate and set the Z0 position. Make sure the cable is correctly positioned so it doesn't snap off the toolbit. Otherwise, if this happens during probing, you will end up with the toolbit going through the touch plate, and this is not going to be a good thing. Now let's lower the spindle. Bring it pretty close to the touch plate. Go to probe module, go to Z. Set a touch plate thickness of 12 millimeters. This is the thickness of my plate. And the probe distance of -10 millimeters, which means it will run for 10 millimeters downwards until it finds the touch plate. If it doesn't find the touch plate after moving for 10 millimeters, it will stop and it will trigger an error. So let's click the button. You can see that it tried 2 times, one faster and one slower. You can change those speeds here in the settings panel. You have the fast find rate and the slow measure rate, 100 millimeters and 50 millimeters. Let's set the X and the Y, and I will do that visually in the corner. It doesn't really matter, it doesn't have to be perfectly aligned. Now let's run the program. I will first close the screen of the laptop, cover it with something, because I'm not sure what is going to happen when I have such a big error for the material's height. And I think it's pretty obvious that this is not what we were looking for, what I tried to engrave. That is because the material is not flat. Let me show you how to solve that using the probe. So this is the 3D probe that I'm using. If you want the exact same model, follow the link in the description. Now let's open the box. I have this probe, of course. I have the cable that is connected to the controller. It has a 6 mm diameter shank. Let's change it and make the probing for the piece of material that we have here. And now that I have the probe in the spindle, let me just connect the cable. It has a USB-C connector, so it's easy to fit here. The light is green. Now the probe is active. But I have one issue in Universal Gcode Sender. If I scroll down here in the DRO, you can see that the probe is activated. I don't know why this happens. I've tried shutting down Universal Gcode Sender, starting it again, turning off the controller. It still has this signal that the probe is on, even though if I go in the web interface of FreeCAD, I can see that the probe is not activated. What works is in the console, $buy, press enter, and now you can see that the probe is not active anymore. Let's test it. Let's touch it. You can see the message appearing here. And when I release the probe, everything goes back to normal. And if for some reason you see the probe randomly activating and deactivating, this means you have an EMF problem, so try to ground everything. If that still doesn't work, what works for me is unplugging the VFD. You can see here the VFD is shown as unresponsive because it is not plugged in. And this helps if you have the probe connected directly to the controller, as I do. Let's move it somewhere where I can safely touch the table. I will lower it as close as possible to the table. And now I can press the probe and 0Z button, but before that I need to change the touch plate thickness because I don't have a touch plate right now. I'm going to use a value of 0 millimeters. The distance is still 10 millimeters because it's larger than the distance from the probe to the table. So let's press the button. Here I have the Z setup using the probe module. Now let's use the probe to set the corner of the material. For that I will go to the XY menu and I have similar settings. The probe X distance, probe Y distance is the distance that it will travel to search to find the material. If it doesn't find the material in this distance, it will stop and you will have an error. The same applies for the X and Y offset. I'm not using any plate, so I won't have any offset. Where does the probe need to be before making the probing for the corner of the material? A little bit below the Y and below the X value. And now that I've placed the probe close to the corner of the material but outside on both X and Y, let's find the corner. After a little while you can see the X and the Y updating. Now I have all of the 3 coordinates ready. Let's do the actual probing. Let's detect the waviness of the material so we can adapt the engraving and we will get good results in the end. One more thing that is really important, you can see here in the DRO, I have the G90 mode. But if I go to the console and scroll down, you can see that the last command was the G91. So this means my machine is in G91 mode, not in G90. What is the difference? If I write here G0X10 in G91, which is incremental mode, it will increase the X value with 10 millimeters. Doesn't matter where it is, it will just increase it with 10 millimeters. In G90 mode, if I write here G0X10, it will go to X equal 10 millimeters position. Let's move to the G90 mode. Let's switch to the G90 mode. Now the machine really is in G90 mode as it is written here in the DRO. Now I can raise the Z and I will do something because I've already engraved this part and I don't want it to interfere with the probe. I will move the X for 10 millimeters and I will tell the machine that here is X0, so it will start from here on. When using the probe, be it for Z, for XY, or for all the 3 coordinates, check here, watch the values here, and check that after the probe finishes its routine, they get updated. Because sometimes these values don't get updated, they are left just as they were before. You believe that you have probed and everything is set up correctly, and it isn't. So make sure you see them changing. This means that the probing has been done correctly. Otherwise, just run the routine again and they will change. So I've moved the machine 100 millimeters to the right, and now the X value is 96.653, and I don't want that. I will tell it that it is X0. The machine will start from this point to the right and upwards. In the auto leveler module, you can see that I already have some settings, and in the visualizer you can see the dots where it is going to probe the material. But let's change it a little bit. Set the starting X to 0 and the maximum value of 100 millimeters. The Y, the starting Y to 0, the maximum to 100, so it's going to be a square with 100 millimeters side. We still need to set the minimum and the maximum for the Z. Let's set a smaller step size of 1 millimeter, move the Z downwards, and a little bit below the material here I have a 31.347 value. Let's set that value, well, it was close, I've tested it before. Let's set a minimum Z of 31 millimeters. This means that if it doesn't find the material when lowering the probe and goes below the 31 millimeters value, it will just freeze, it will throw an error and it will stop. Now let's do the same for the maximum Z. Let's raise the probe and visually look for a position where you're sure it's not going to touch the material in any place. And I have a value of 47 for the Z. Let's write it here. And I have 3 more values here. The resolution is the distance between 2 consecutive points. If the surface is continuous, you can use a higher resolution because when creating the beziers based on the probing points, it will look exactly the same as the original. If you have a very bumpy material, using a lower resolution will help map that material correctly. I'm not going to use the G-Code Z surface, I'm going to leave it at 0 because there's where my origin was, so I don't need to change that. And the Z retract value, a value of 30% is okay in my situation. The steeper the slopes, the larger the Z retract should be. Check the show preview, uncheck the applied to G-Code for now, and we can click on the scan surface button. So the probing is ready. Happily, I should save the scan, click on this button, but don't. I recommend when you are going to use the probe for the first time, just set a 4 points scan and try the following thing. After the scanning is ready, click on the save scan. Why do I recommend that? Because in my situation on my computer, if I click on this button, Universal Gcode Sender will simply freeze. The solution to that, if you have problems with Universal Gcode Sender freezing, is close the visualizer first, then go to save scan and click on it. So let's name it surface scan.xyz. I'm using this extension because it works okay both in Universal Gcode and in FreeCAD. Click on the save button and you have the scan saved. Now I can go to Window and click on the visualizer to open it again. I don't know why this happens. It should be solved in the future probably, but until then I suggest testing it before running a probing sequence of hundreds and hundreds of points, which take a lot of time and losing everything. First, test it on a 4-point scan. Click on the Save Scan button and see if Universal Gcode Sender freezes. If it does, remember the solution is to close the visualizer and then save the scan. Now that we are back in FreeCAD, let me show you how to use the file that contains the scan points to adapt the G-code so we get the correct engraving in FreeCAD. Don't worry, if you're not a FreeCAD user, I will show you in just a couple of minutes how to do this no matter what program you're using to create the G-code. Open the operations group and select the engrave operation. Click on this little icon here in the dress ups group. If you don't have it here, maybe you're using version 1.0, or if you find it difficult to click on this little arrow, you can go to the CAM menu, pass dress up, and here you have Z-depth correction. Some of you may have seen my other videos about using this dress up. When I always click OK, I never select a file. Well, this is the time that we are going to select a file. Click on the three little dots, select the surfacescan.xyz file, and now we can click on the OK button. And after a few moments of thinking, I can see that I have the G-code adapted to the surface that we have scanned. There's one thing you need to take care when using the Z-code dress up is the safe and clear as height. You can see that they are not updated by this dress up. Probably this shouldn't be fixed in the next versions, but for now they don't get updated, so you have to go to the operation, go to heights and change the clearance and the safe height. If you cannot change them, the icon for the expression is dark blue. This means it uses an expression, so open it and click on the reset button. And let's set the value for the safe and the clearance height equal to the one that we have used when scanning the highest Z value. Click on OK and we'll still have a downside. It will go upwards from the surface with that value. But my machine can handle it. Make sure your machine can handle it. Otherwise, you will need to use the other method that I will show you in just a couple of minutes. We can now export the job and go to the machine to mill it. Before doing that, let me show you something that is really useful, especially when you are having some trouble. Let me delete the Z-code dress up for now. Let's select the model and let's move it, let's say, less on the y-axis so it goes a little bit outside. You can see that this is below the Y0 value. And I've done this to show you what happens when the scanned file won't cover the entire area of the G-code. So let's select again the Z-depth correction dress up, click on these three little dots, select the surface scan file, click on OK, and you can see here I have an error. It needs a recompute, and when I recompute it, it shows me a list index out of range. This generally means that the scanned area doesn't cover the entire G-code, but how can you see that? I have this object which sometimes is visible, sometimes it's not, it's the surface, but I also have a macro that is really useful in this situation and is also really useful whenever you want to use that scanned surface to convert it into a solid. As usual, you can download the macro from the link in the description. Go there, download it for free or together with a small donation. Let's use it and see what happens. Select the points to surface macro, select the XYZ file, click on the open button, set a thickness. I will use the default 10 millimeters, click on OK, and you now have a solid. That is the perfect representation of the scanned points. Now let's rotate the view from the bottom, click on button here, and we can easily see that the G-code is going outside of the scanned surface here. So let's select the model logo and increase the Y value until it fits in this area. Well, now it goes outside, so I need to lower it a little bit. Now it is fully constrained inside this scanned area. Let's start a recompute. And now the Z-code dress up works as it should. So if you are having problem, if you somehow don't match the two surfaces, you will have that error. Using the macro to generate the solid of surface will help you diagnose this problem. Of course, you can use this solid, intersect it with a cube, for example, and you will have a perfect replica of the material on the CNC table. You can manipulate it however you want it from now on in the part workbench. Now let's go to the machine and run the program, see what happens. Let's first unplug the probe, remove the probe from the spindle, fit the V-bit into the spindle, and then we will have to reset the Z value using the tool setter this time. Let's place the tool setter plate this time on the real value on the face of the table. You need to set the toolbit height exactly in the same place where you've set the probe's height. Otherwise, you might end up with some differences, which of course can create a lot of problems. So let's move the toolbit above the touch plate. Lower the Z. Maybe move it backwards a little bit. And now let's go back to the probe module menu, go to Z, set the touch plate thickness to 12 mm, that's the thickness of the plate that I'm using. And now let's click on the probe and 0Z button. Make sure the Z value has changed. Let's press play and see what happens. And let me show you the incredible difference between the two engravings. Of course, in real life situations, you won't have surfaces with such a difference in their flatness, but differences will be there. You will have different thickness for the lines. When scanning, everything will be exactly as you want. And I told you that this can also work using Universal Gcode Sender, and it will also solve one problem, which is these too high safe and clearance values which cannot be fixed in FreeCAD. Let's load the initial file, the one at Z0. Let's go to the auto leveler menu, and we don't have the scan available now, but we can click on the open scan button, select the file, click on open. If you take a look at the apply to G-code checkbox, you can see that it is applied. Well, there is a small problem here. You remember why the Z-surface correction wasn't working in FreeCAD? Because this was slightly outside of the scan surface. In Universal Gcode Sender, it won't affect the initial G-code, so this point will be at Z0. There's something that we really don't want. So in order for this to work, let's go back to FreeCAD, open the initial file, go to the model, and I remember this was set at 99 instead of 98. Now re-export the file, go back to Universal Gcode Sender, and when clicking again somewhere in the G-code, you can see that the file has updated with the one exported from FreeCAD. Now everything looks exactly as I want. It is corrected, it has the Z height corrected, fitting exactly the material, and now I can simply press on the play button and it should do exactly what I intend with the correct height, both for the milling and for the free movements for the safe and clear as height. You can see them. They are also corrected to the surface. Let's press play and see what happens. But there's a really important thing that I forgot to do, and let me show you the results. It plunged all the way to Z6. And before I had the time to press the emergency stop button, it entered the material with a very low height. Luckily, it doesn't seem to have affected the toolbit, the spindle, or anything else. But let me explain you why this happened to me and how to take really good care how to avoid doing that. I now have the motors stopped. I don't have power to the motors, but I still have the controller connected so I can show you what happens. Let's press the play button just as I did earlier. And you can see the deep plunge. Here again, another deep plunge. And only after that, it will keep on milling at the correct height. I will stop it right now. Again, the machine is not moving. You can see it here simply staying in place because I have turned off the power to the motors. Now let's stop it and let me explain you what happens here. You can see the G-code that FreeCAD has generated, and I have a bunch of G0 commands. Then it starts milling with a G1 command. Any G0 movement that is here before the G1 command is not applied by the auto leveler applied to G-code routine. So in order to avoid this happening, let's say I have the toolbit somewhere here as I did earlier when you've seen it crashing. In order to make sure that I don't have any issue here, take a look at the G-code and delete all the Z movements before the first G1 command. I don't need to delete the X and Y values. That is because I first needed to go into the starting position and then lower. If I delete this one, it will simultaneously go to those X and Y and to the Z-1, which means it will travel like this through the material. So remember, delete all the Z movements with the clearance and the safe height before the first G1 command. But there is an even better solution than deleting and altering the file before seeing it, because you can see here I have the original file, I don't have the updated file. I have this button here, export G-code, which will export the updated file. Again, my installation has some issues, so I will close the visualizer, click on export G-code button, save it, and now I can close the auto leveler, open the visualizer again, and let's open the file. And we can see in the visualizer the representation, and we can easily see the Z6 commands that haven't been updated. These are the two commands that will create some problems. Just delete them from the G-code. And now, after saving the file, we can see clearly that nothing is wrong here. So I strongly suggest that before running the updated G-code file, save it somewhere else, close the initial file, open the Z-height updated file from Universal Gcode Sender, and make sure you don't have any wrong movements, so you won't end up with a toolbit crashing into the material as you've seen happening to me. Thank you all for watching. I hope today's video was really useful. Don't forget that if you want to see all my videos without any interruptions, without ads, you can do that by subscribing to my Patreon page. I hope I convinced you that this probe is a really useful addition to any CNC, and it can improve a lot any type of job. Thank you for watching, and see you next time.